Hello, Dr. Harris back for another video in our series on inference for means, Chapter 7 in our MAT111 course. And in this video, we're going to be looking at how we handle confidence intervals and hypothesis tests when we've got paired data. And the good news, I suppose, is that the work that we're going to do in the end looks very, very, very much like the things we've done for a single mean. The big difference, the only difference the only extra step in some ways that we have to perform here is that we need to compute the differences between our paired data values before we do any statistical computations. So we're going to be assuming that we've got two measurements, recall, from the same set of individuals, and we can do a direct comparison by, for each individual, computing the difference between the measurements. And in doing so, then we can compute the mean of those differences. We have a single mean, and so therefore the work that we do with finding confidence intervals using PTGC, using t-test GC will look very similar to what we've done before. So let's go through an example. And so this is a data set that's addressed in a document that I've placed on Canvas that you've already worked through a little bit, I hope. And there's a file called jobsatisfaction.xlsx. It's an Excel spreadsheet that's in our Dr. Harris stuff folder. We're going to go there in just a minute and take a look at it. And we're going to see how we can import that data into our studio to work with it. But if you recall from looking at this document in advance now, there were two surveys done at a company about job satisfaction, one before an exercise break was instituted, one after an exercise break was instituted. And they have results of 10 surveys from the same 10 people, employees in the company. And so this is paired data. We've got a before score for each individual, and we have an after score for each individual. And we're trying to determine whether or not there was a difference in job satisfaction as a result of the institution of this exercise break. So let's see how we're going to import the data into our studio. So we're going to be looking at this data file in the Dr. Harris stuff folder. It's in the base level directory in the folder. We're going to click on the file name and select import data set. So let's go over there for a second. Here is the Dr. Harris stuff folder, the contents, and here's jobsatisfaction.xlsx. So if I just click on the name and I choose import data set, I get a panel that pops up. And we see that there's a little bit of information here, and there's a blank row, and then I got before and after. And so I'm not going to want to import this information up here, and I probably don't want this blank row either. So actually I want to skip the first couple of rows that I've got in my spreadsheet. So how do I do that? Let's see. On the panel that comes up, enter 2 in the skip window and hit import. So here's the skip window right down here. I'm going to say 2. That tells our studio to skip the first 2 rows of my data, and then I'm going to go over here to import. I'm going to click it, and well, look there. Here is our data set imported into our studio. Cool. And if you look at the document that I posted on Canvas, these are the scores that match up. And so I've got employees 1 through 10. Employee 1 scored it as 34 before the break, 33 after. Employee 5 scored 26 before, 37 after, etc. So our data has now been loaded into our studio. It's a useful thing to know how to do. Okay, so if we want to, before we begin, this is a pretty small data set, only 10 individuals, and so we really want to be pretty sure that our data is relatively symmetrically distributed without any big outliers. And we also, and if once that checks out, then we'll need to know what my mean and standard deviation are. So let's run these 2 commands here. Let's run density plot to see what we've got. So density plot, well, given that we only 10 data values, that doesn't look too bad. There's a little bit of something right there, but this is a pretty symmetric one. This is actually very good for a small sample size, and we should feel pretty comfortable proceeding based on the relative uh, symmetric bell-shaped nature of this 10 point data set. And then, so now we feel good about going on. We assume the employees were randomly chosen, and so we can run fave stats. And so the output is on the next slide in my slideshow, but let's just focus real quickly. Our mean is 8.5, and our standard deviation to 3 decimal places is 7.472. Okay, that's here on the next slide, but it's a little bit hard to read. But here's our mean, 8.5, and here is our standard deviation. And our sample size is, of course, 10. So we've got this information. And so now we want to think about, if I'm going to form a confidence interval, I need to determine what T star is. Well, how many degrees of freedom do I have? If my sample size is 10, I've got 9 degrees of freedom. And if I'm going to form a 95% confidence interval, I need to look in the third column for 9 degrees of freedom. And it looks like 2.26 is going to be my value of T star for a confidence interval. So we can do that here. 2.26 is indeed T star. So our confidence interval goes from the mean, 8.5, minus T star times the standard error, which is 3.16, to 8.5 plus T star times the standard error, which is almost 14. And so we're 95% confident that job satisfaction scores improved. We were doing, if you go back and look at it, I sort of glossed over this, but we're doing after minus before. So if we're thinking, I tend to like to think about positive numbers when I can, and if I'm hoping that instituting this exercise break would improve scores, then we'd expect the after job satisfaction scores to be bigger than the before, and so I'm doing after minus before here, and so a positive number means that scores improved. So we're 95% confident that the scores improved by between 3.16 and 13.84 points. So that's our confidence interval. To do our hypothesis test, our null value usually in these situations is, as we mentioned way back in the first slideshow for this chapter, we typically say that the mean difference is 0, that there was no change, whereas our alternative hypothesis is going to be that there is one. Recall, to do the hypothesis test in this section, we need a t-score. And so we take the sample mean 8.5, subtract the null value 0, divide by the standard error, and we get almost 3.6. So our p-value is going to be PTGC applied to the interval from negative 3.597 to 3.957, Our region's outside, 9 degrees of freedom. So remember, we're checking to see if how likely it is to get something as far away or farther on either side with a two-sided alternative hypothesis. So if we run PTGC, we get a p-value of 0.006. That's pretty tiny. Here is our graph. And so I'm going to let you get some practice here on writing the interpretation of the p-value. Remember, it's in the form of, if the null hypothesis is true, then the probability. So when we translate if the null hypothesis is true into the context of the situation. So I'm going to let you get some practice on doing this, and we will talk about this in class. If we run t-test GC, because I'm going to use the summary data this time, our mean was 8.5. Here's our standard deviation, our sample size, our null value. It's a two-sided alternative. So if we run this, we do get very similar confidence interval. And here is our p-value. Again, it's very close to what we had before. So again, I'm going to let you get some practice on making those decisions without me spelling it out for you. And then finally, I've got something else for you to do. Here's some data. So there is some pair data in our MAT111 survey data set. Remember that two of the variables that are in there are the height of the student surveyed and what the student considered their ideal height. That's a very natural choice for pairing data up. And so we want to ask, do students wish they were a different height from their actual height? And so I'm going to have you state the parameter of interest in words, test the conditions. Let's get some practice forming the confidence interval and conducting our hypothesis test using PTGC. And then we can use t-test-GC by just directly entering the data name, or the name of the variable and the data set into t-test-GC. We might need to talk about a little bit more specifically in class, but we will definitely do so. And I look forward to talking with you about this, and just let me know what to do.